Welcome to The Explainer. Today we're thinking big. I mean, really big. We're not just looking at blueprints for buildings, we're exploring the engineering plans for entire worlds. These are some of humanity's most ambitious, mind-bending construction projects. And believe it or not, they're all grounded in real physics. Let's dive in. So what if our next giant leap wasn't about finding another planet, but about building one from scratch? We're talking about creating ecosystems on a scale that absolutely dwarfs anything here on Earth. This is where science fiction starts to look a lot like an engineering roadmap. All right, so where do we even begin with a project this massive? Well, let's start with something that's, almost relatable. A self-contained city floating in space, orbiting our sun. It's a concept known as the O'Neill cylinder. Yeah, back in the 70s, a physicist named Gerard K. O'Neill dreamed up these incredible habitats. This particular design, which he called Island 3, wasn't just a fantasy. He saw it as a really practical next logical step for humanity to expand out into the solar system, creating permanent homes for millions of people. And the design is just, well, it's elegant. It's so clever. You have two cylinders spinning in opposite directions, right? That cancels out any gyroscopic wobble, making the whole thing incredibly stable and super easy to aim right at the sun for power. That spin also gives you Earth-like gravity on the inner surface. And then you've got this system of giant mirrors and windows to create a totally normal day-night cycle. The inside is so vast you could literally have your own weather systems, your own clouds forming overhead. So an orbiting city is one thing, and it's amazing. But what happens when our ambition scales up? What happens when we go from building a city to building an entire world? The engineering challenges, as you can imagine, become truly astronomical. And that brings us to the Ringworld. Now, this isn't just a habitat in orbit. Oh no, this is a structure so massive it completely encircles its star. Imagine a ribbon of land, 1,000,000 miles wide, wrapped around the sun. This idea was first dreamed up by the author Larry Niven, and just to give you a sense of the scale, a ring world built where Earth is now would have a mind-boggling amount of living space. We're talking the equivalent surface area of 3 million Earths. It is the ultimate piece of cosmic real estate. But of course, there's a catch, a huge one. A structure that massive, spinning fast enough to give you gravity, is under an unimaginable amount of stress. As physicists were very quick to point out, it's a structure that is desperately, violently trying to tear itself apart. So here's the fundamental problem. To get 1 g of gravity, that ring has to be spinning at over 1,000 kilometers per second. That speed generates this constant outward-pulling force, what we call tensile stress. And it's so immense that no material we typically use could possibly handle it. Let's just look at the numbers here because they're wild. Structural steel, it can handle about 0.4 gigapascals of stress. It wouldn't last a nanosecond. You need something that can withstand around 34 GPa. But then, look at carbon nanotubes. Their proven strength is nearly double what's required. And just like that, the impossible starts to look, well, maybe not so impossible after all. Okay, so let's say you've done it. You've found a material that won't snap under the strain. Problem solved, we can all go home, right? Not quite. There's a much more subtle danger here, a hidden flaw in the physics that could be even more catastrophic. See, unlike a planet, which sits nicely in a stable orbit, a solid ring is inherently unstable. It's kind of like trying to balance a hula hoop on the tip of your finger. The pull of gravity on the side of the ring closer to the star is always going to be a little bit stronger. So any tiny nudge, a meteor strike, a big solar flare, it's going to start to drift off center. And that drift leads to an inevitable fiery collision. The engineering fix for this is something called active support. Basically, it means the ring world has to be a smart structure. It needs massive engines, attitude jets that are constantly firing, constantly making tiny corrections to push it back into the perfect center. So it's not enough to just build it, you have to actively fly it forever. And this kind of complex, active engineering, it leads us to our final and by far most ambitious megastructure. This is one that shifts the entire goal from just creating a place to live to capturing a level of power that's almost godlike. This is where we get to the crucial point. Why would you settle for building a world that just uses a tiny fraction of a star's light when you could build a megastructure that captures all of it? Now, when most people hear Dyson Sphere, they picture this solid, rigid shell completely enclosing a star. But just like the ring world, that's incredibly unstable. The much more practical idea, which physicist Freeman Dyson actually proposed, is a Dyson swarm. Think of it as a massive, dense cloud of independent solar collectors, with each one in its own stable orbit around the star. So, how on Earth could we ever build something like that? Well, another physicist, Stuart Armstrong, laid out a surprisingly logical plan. It's an exponential process, like a snowball rolling downhill. You start small, with just a few collectors to get some power. You use that power to send robots to mine a planet, let's say Mercury, for raw materials. You then launch those materials into orbit to build more collectors, which gives you more energy to mine even faster. Each step just feeds the next, creating this self-replicating cycle of construction. And this is what really drives home the colossal scale of this project. We're not talking about mining in the traditional sense. We're talking about planetary disassembly. To build a complete swarm, you'd need to take apart entire planets for all their raw materials. And the reward for all this planetary scale construction? It's the ultimate prize. You capture 100% of our sun's energy output. That is 400 septillion watts of power. It's an amount of energy that would just elevate a civilization to a completely new level of existence. So, what does all this mean? I mean, from cylinders to rings to entire swarms of collectors, these unbelievable galaxy-spanning engineering projects, they aren't just about building big things. It's about what these projects tell us about our own potential. Look, these concepts might feel like pure science fiction, but it's probably better to think of them as blueprints. They are thought experiments, all grounded in physics, that are basically mapping out a potential new frontier for a species that is always looking to build the next biggest thing. From the O'Neill cylinder, which feels almost achievable, to the planet-consuming Dyson swarm, each of these structures is really a proposed solution. It's a solution to the huge long-term problems of energy, space, and ultimately survival. And that kind of leaves us with a final thought, doesn't it? These megastructures are maybe the ultimate expression of that human drive to build, to explore, and to solve problems that seem completely and utterly impossible. So I'll leave you with this. What do you think these incredible blueprints for our distant future really reveal about the boundless nature of human ambition and ingenuity?